Hello everyone, let's look at this integral here. This is the integral of secant x. And this is an important integral because by finding this integral, we have the antiderivative for the secant function. Okay, so let's get started for this. So first, for the secant function, what we want to do is that we gotta multiply the secant function by something so that we'll turn it into a different form. Because right now, if you just look at the secant function right here, we don't really have anything to work with, as you can see here. So what we are going to do is that we are going to multiply the numerator and the denominator. So we are going to multiply the numerator and the denominator. Okay. By secant x plus tangent x, and then we do the same thing at the bottom, right? If you multiply something at the top, then you would do the same thing at the bottom, so that basically we are not changing the integral, we are just multiplying by 1, and then we have the dx right here. Okay, and so now we just distribute the secant x to the secant x and the tangent x in the numerator. And so that will actually give us what? That will actually give us, if you multiply the secant x times the secant x, we are going to be getting secant square x. And then plus, now if we multiply the secant x and the tangent x, then we are going to be getting secant x. And then tangent x. Okay. And then in the numerator, the denominator, we are still getting the just the secant x and the tangent x, right? So just the secant x and the tangent x. And then there's a dx right here. Then you may say, doesn't that look more complicated? What we can do right now is that we can make a u substitution. Okay, so we can do a u sub here. So what we are letting u be is that we are going to let u be the secant x plus the tangent x. Okay, so we are just going to let u be this thing. And then now we need to find the du, right? So du is equal to, what is the derivative of secant x? It's actually secant x tangent x plus, and then what is the derivative of tangent x? We are going to be getting secant square x, and then the dx. Okay. So now, if we just look at this expression right here, there was a secant x, tangent x, and we do have a secant x, tangent x right here. And then we also have the secant square x, right, adding. And so we also have the secant square x, and then we actually are having that too. And also we do have the dx right here. So we also have the dx. You see what's going on here? We can actually replace this secant square x plus secant x tangent x and the dx all together by the du. Okay, so we can just replace all that. And then, of course, we can replace the bottom, right, which is the secant x plus tangent x. We can replace that by u. And so now we turn our integral into an integral with what do we have in the numerator? It's just the du, right? It's just the du. Just the du in the numerator. And what about the denominator? The denominator, it would just be what? It's replaced by the u. So we have the u right here. And this is a really simple integral that we can integrate. If you don't recognize this form, you can actually write it as the integral of 1 over u, right? 1 over u. And then times the du. You see what's going on here? Do you recognize this function? It's actually easy to integrate. Its antiderivative is actually the ln of the u, right? It's just ln of u, and then plus the constant of integration. And then right now, all we need to do is to replace the u by this expression, right? We switch back to our original variable x. And so we are going to be getting ln of absolute value, and then the u is the secant x plus tangent x, and then plus the constant integration. So this is the antiderivative of the function secant x. Okay, so the way to do it is to multiply the numerator and the denominator by secant x plus tangent x, and then after that we are going to do a u sub, and then we will get the answer. Okay, so that's it for this problem. If you like my video, please subscribe my channel, give me a like, and leave me a comment, and then also please check out my other videos. Thank you for watching this video. I will see